All right, so we are going to start 8.1 today, which is the law of sines and cosines. Now we're going to start with the law of sines. Okay, it's 8.1. Hopefully you can see that. All right. So the law of sines basically is used to find missing sides or missing angles in any size triangle. It doesn't have to be a right triangle. So the trig moves on now to help you find that with any kind of triangle. So I'm going to draw a triangle here. I'm going to label this angle A, capital A. This is capital B. And this angle, capital C. Now, these are for the angles, mind you. The side opposite angle A, we're going to say its length is little a. The side opposite angle B is little b. And the side opposite angle C is little c. The law of sines says that if you take the sine of angle A over the length of side A, it is equal to the sine of angle B over the length of side B, and the sine of angle C is equal to, you guessed it, side C. Now you don't have to use all three at once. You can use just that pair, just that pair, just this pair. It's whatever you want to use. So let me give you a couple of examples. Let's say I give you this triangle right here. And I'll tell you that angle A here is 118 degrees. Angle B is 22 degrees. And I know this side is 24. Let's find the length of BC. Let's find little a. Because this would be small b and this would be small c. And on the Truman, it's going to ask you to find all the missing parts. That should be little a, sorry. This is c, of course. So what we need to do is we have to find an angle and its opposite side. So we know this angle is 118, but its opposite side is A. This angle is 22, but its opposite side is B. Well, what I can do, can I figure out what angle C is? Of course I can. I need to take 118, add 22, which gives me what, 140 degrees? I know then that angle C has to be 40 degrees. So now to find A, I can say the sine of 40 degrees over 24 is equal to the sine of 118 over A. And then I'll cross multiply because it's a proportion. So A times the sine of 40 equals 24 times the sine of 118. Next step to find the A would be to divide by the sine of 40. So A is equal to, now when you get your calculator, make sure you're in degree mode. First thing I'll do is make sure I am. So here we go. 24 multiplied by the sine, of 118, close the parenthesis, divided by the sine of 40. Tells me that A is 32.9, we'll go 97. Now, I want you to think about that for a second. We know from geometry that the largest angle should be opposite the largest side. So if this is 40 degrees and this side is 24, 118 should be bigger, which it is, isn't it? And if we were to go ahead and find little b, the only other piece we're missing, which we could go with the same thing of the sine of 40 over 24 equals the sine of 22 over b. When you cross multiply, you get 24 sine of 22. Sorry. Equals b times the sine of 40. Divide by the sine of 40 degrees. Divide by the sine of 40 degrees. So in the calculator, you just do 24 times the sine of 22, close that parenthesis, divided by the sine of 40. And I got b to be 13.99. So this guy is 13.99. So we solved this triangle. We found the missing angle just by using the fact that all three angles have to add up to 180. And then we used the law of sines proportion to find those missing sides. Hopefully that makes sense. We'll do a couple more just to be sure. So over here, I'll label this as to find the B. To find angle C. Okay. So let's go backwards and let's find an angle. Here's triangle A, B, C. This is 82 degrees. This is 29. This side is 24. And this side is 20. We're going to find angle B and angle C. Those are the only two pieces we're missing. So we already know this angle, its opposite side. So we can say the sine of 82 degrees over 29 equals, let's do B. Let's do sine of B over 24. Cross multiply, 29 times the sine of B equals 24 times the sine of 82 degrees. Divide by 29. The sine of B, so here we go, 24 times the sine, what is it, 82, divided by 29. All right, now I want you to keep that there for a second. So we know the sine of B is 0.8195, blah, 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 blah. Well, once you know the sine of B, to find B, you can't divide by sine. You have to take the inverse sine. So we have to take the inverse sine of that answer. Now, I've said this and said this, but maybe this time it'll click. See, I already have that stored there. So I do second sine. Rather than type all that in, second, the negative keys. See, you should all have a button on your calculator that says A and S, which stores the previous answer. It's a lifesaver. Find that, press enter. There's our angle, 55. We're just going to make it 55.04 degrees. So this guy is 55.04. Now I can do this again to find angle C, or I know for certain what do those three angles have to add up to? You guessed it, 180. So take 55.04 and 82. So I got 55.04 plus 82. Take 180 minus 137.04. Angle C is 42.96 degrees. What do you think about that? All right, I'm going to try another one for law of sines. I don't have a lot of room. Need a taller stand, I guess. So let's try this one. Now, for this one, if I don't give you an angle, this would become a law of cosines question, which is very doable, but I haven't shown you those formulas yet, so that'll be in the next video. But let's say I tell you this is 97 degrees. So to find one of those missing angles, you've got that pair right there. You'll do sine of 97 degrees over 22. Let's do C. Sine of C over 19. So 19 multiplied by the sine of 97 degrees equals 22 multiplied by the sine of C. Divide that by 22. So 19 multiplied by the sine of 97 divided by 22. So I get 0.857198 equals the sine of C. And of course, you know we have to inverse sine that. So in that calculator, inverse sine that answer, 59, we're just going to go 59. So C is 59 degrees. So then B, if I take 97 and add 59, I get 156 degrees. 180 minus 156 is 24 degrees. So angle B must be 24 degrees. And I'll just double check that. 97, 59, 24, 180. So we're good to go. Now the next part of the law of sines is going to be a little trickier. It's going to ask you to find, sometimes when they give you angles and side lengths, they do not make triangles. And sometimes you get a situation where this one side can either be out really far or you can swing in and be very close, kind of like that. So we have the possibility of the dimensions given making no triangle, making one triangle, or possibly making two. So I'm going to show you how to figure that out. So how many triangles are possible? And basically, if you remember in geometry, when we talked about congruent triangles, we did side, angle, side, 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 angle, angle, side, but we did no angle, side, side, and we always laughed because it was a bad word. Well, when you have that ambiguous case, which we're going to call side, side, angle, that's when the situation shows up where you could possibly have no triangle, one triangle, or two. So let me show you what that looks like. So let's say I give you that the measure of angle C is 63 degrees. Side B is 9 and C is 12. So what I do is I just draw a triangle first. I'm going to label it A, B, and C. I'm going to put 63 here. Opposite of B is 9. Opposite of C is 12. So I'm going to find angle B because I don't know anything about A. I don't know its angle or its side length. So I know the sine of B over 9 will equal the sine of 63 degrees over 12. And I cross multiply and divide. So 12 times the sine of B equals 9 times the sine of 63. You divide by, 12. And we get the sine of B is, hold on a second, 9 times the sine of 63 degrees divided by 12 is 0.66825. And then of course to get B, you have to take the inverse sine. So inverse sine, that answer, B is 41.93 degrees. Now here's the thing. You have to check because there's two options for an angle having that sign. Remember on the unit circle that an angle here its XY value has the same, it's a negative X, but same Y value, correct? So 41.93 degrees, if this is 41.93 degrees from here to here, it has the same sign as this angle. So to find that, you take 180, subtract 41.93, and it could also be 138.07 degrees. So B could be both of those. Now here's how you tell how many triangles are possible. You already have angle C. Angle C is 63 degrees. If you add 41.93, which is, let me start that over. You know angle A plus angle B plus angle C has to equal 180, okay? We don't know angle A, but we know angle B. We're going to start with the first one. 41.93 plus 63 equals 180. This is definitely smaller than 180, so this one for sure works. We definitely have one triangle because there's room for angle A. But if we check this guy, if we say angle A plus 138.07 plus 63 has to equal 180. See how these two are already greater than 180? It's not possible. Therefore, there's only one option for angle B because it leaves room for angle A. So this one would be one triangle. I hope that makes sense. We'll do another one so that you'll have a chance to look at it. But that's how you figure it out. So let's try another one. Okay, so let's say we have the measure of angle B is 33 degrees, A is 27, and B is 22. And I'm going to do this a little smaller so I can fit a couple on this page. Here's A, B, and C. So B is 33 degrees, not drawn to scale. Opposite of A is 27, opposite of B is 22. So here we go. You have this pair, so let's find A. So we know the sine of A over 27 equals the sine of 33 over 22. So 22 times the sine of A equals 27 times the sine of 33. Divide by 22. The sine of A is 0.6684. So then you inverse sine that answer. And you get angle A is 41.95 degrees. Okay, now remember, 41.95 degrees has a twin over here, so you have to do 180 minus 41.95. It could also be 138.05. And then you have to check. So here we go. Let's start with, now those are my choices for angle A. So I'll do 41.95 plus 33 plus angle C equals 180. And then I'm going to do 138.05 plus 33 plus angle C equals 180. And see if I have room for angle C. In this situation, angle C would be 180 minus 33 minus 41.95. Angle C would be 105.05. And in this situation, if I get an answer for angle C, I'm going to have two possible triangles. 180 minus 138.05 minus 33, or it could be 8.95 degrees. So see how this has two possible answers for angle C. That means I have two possible triangles. That's why in geometry, angle side side doesn't work, because it doesn't lock in that third angle. Does that make sense? This guy, because of these lengths, this guy could swing here. It can also come in closer and touch probably about here, because that's a small angle. It's not drawn to scale. But because angle C is not locked in, this angle can move. This guy stays the same and this guy stays the same. But when you bring this in, this is the only angle that changes. So it can be really large or it can be really, really small. All right, so let's try another one like this. Let's say I give you the measure of angle B is 95 degrees, B is 24, and A is 5. So let's just draw that out. So here's A, B, and C. Hopefully you can see that okay. So this is 95 degrees. This side is 24. This side is 5. So we're going to find angle A. We're going to say the sine of 95 degrees over 24 equals the sine of A over 5. So 5 times the sine of 95 equals 24 times the sine of A. Divide by 24. Sine of A is 0.207 something. So then we inverse sine. I get 11.98. Okay, so remember 11.98, really small angle, but it has an identical twin over here. So you do 180 minus 11.98. So it could be 11.98 or, sorry, 168.02. We know angle B is 95 degrees, correct? So if we did 11.98 degrees plus 95 degrees plus angle C, it has to equal 180. And if we do the other one, 168.02 degrees plus 95 degrees plus angle C has to equal 180. Well, this is way too big. No good. Here, that gives you like 107? Plenty of room for angle C, correct? Therefore, we only have one possibility for angle A, meaning there's only one triangle. Sorry if I didn't let you see that. Only one possibility for angle A because 168.02 with a 95 degree angle is just too big. It's already greater than 180. Let me show you an example of no triangle, and then we'll move on to law of cosines. Okay, let's say the measure of angle B is 35 degrees,